Before we get into the details of the weave engine, let's talk about the weave itself. The idea behind the weave engine is something like this. Let's say we have a horizontal thread like this. It's gonna go above a number of vertical threads like this, and then it's gonna go below another number of vertical threads like this, in this case 3 threads, and then it will go back up another number of vertical threads, in this case another 4 threads like this, and it's gonna repeat for every horizontal threads like this. And for each of the horizontal threads, the pattern will be shifted by a number of threads. For example, if this pattern is shifted by 2 threads, then it's gonna be something like this, right? So you see, this pattern is controlled by 3 numbers. The up number is the number of threads that go below the horizontal threads, and the down number is the number of vertical threads that go above the horizontal thread, and another number for the shift. So that's the idea behind the Weaver engine. So yeah, let's go ahead and implement this idea. Okay, let's move everything back a little because we're gonna need a lot of space for this algorithm. All right, we can now create a combine XYZ. The first number will be the up value, this is the down value, and this is the shift value, all right? And we need natural numbers, right? Not floats. So we need to force this into natural number, and the numbers can't be lower than 1. So create a vector math node and use maximum. There we go. 1. So if any of these numbers is below 1, it's gonna be set back to 1, like so. And next we will floor the numbers like that, so we can have float numbers. And we can now separate XYZ to use these numbers however we want. So create a math node, we must first add the X and Y together. And we also need to separate the X and Y for this scale value. Now, we need to floor the Y value like this. So we have individual rows like this, right? And we will multiply this by the shift value, which is the Z dimension of this node. And next we need to subtract the X value with this particular value, like this. So we have something like this, all right? So far so good. Now we need to cut this into repeating pattern. So we will use a floored modulo math node. And for the second value of the floored modulo, we will use the sum of the X and Y. So we will add the X and Y together like this. There we go. So let's set this to 3 and this to 2. So we have a pattern of 5 threads. 1, 2, 3, 4, 5. Okay, so we have 5 vertical threads going through each of these segments, like so. Now, at this stage, if you get something like this, then you are on the right track. However, if you get something different from this, then I suggest you go back and try to fix the problem before continuing the tutorial. Otherwise, you will end up with some serious problems that will be very hard to fix later on. Now, from this modulo value, we can now create the displacements for the horizontal threads, okay? So let's say this is one segment, all right? We will have 3 threads going up and 2 threads going down, right? So for this part of the segment, we need to displace it up, and for this part of the segment, we need to displace it down, like so. And the total length of the segment is 5 threads, okay? So first, let's make the upward displacement using this modulo value. So create a map range node and connect this value into this node like so. First, we will separate half a tile like this. This will be the transition between the downward and upward displacement, right? So it's basically like this, all right? This is the transition between the up and down displacement. So this will be from 0 to 0.5. There we go. And next is the downward displacement. It's going to be something around here. So again, we have the transition between the upward displacement and the downward displacement. So it's going to be like this. Okay. So it's going to be on the third square from the left. Okay. So anyway, let's go back here at this X value. Okay. We will create a math node And this time we will use a subtract node. There we go. And this will subtract by 0.5. And let's move it here and manage the wire a little bit, like that. All right. Now, Control-Shift-D to duplicate this map range node and connect this to the from min value, like that, and this to the max value. So this is the x value, and this is the x value minus 0.5. Okay, and the x value is the up value, all right? And this one will be 1 and 0. So we flip the value. And now we will combine these together using a minimum node. There we go. We have something like this. Okay. And there is a problem with this displacement, is that it's perfectly linear displacement like this. And I need a curved displacement like that. Okay. And the easiest way to do this is using a float curve node. There we go. And we have a very nice curved displacement. Or maybe I should do something like this. Okay. So this is the upward displacement. Next, let's go ahead and create the downward displacement. Again, we will use these nodes, okay? But this time we will select this region. So it's gonna be from 3 to 5, all right? Duplicate a math node and change this to add. And this time we will add this x value with 0.5, like so. And connect this to the from max value of this map range node, okay? And again, we will connect the x value to the map range node, but this time we will connect it to the mean value. And flip these values, 0, 1. Okay, we have something like this. So you see, we now have a very nice transition for half a square, like this, all right? And next we need this transition here, okay? So for this map range node, we will connect this add value here to the from max value and subtract 0.5 from this add value, like that, and connect it to the from mean value. And again, we will flip these values. Okay, so we have something like this. And again, we can combine these together using a minimum map node. And once again, we also float curve it to make it a curve displacement. Okay. And finally, we can combine these two together using a subtract node. We will subtract this. This will go to the first slot, and this will go to the second slot. So we have something like this. So here we have the value of 1, and here we have the value of -1. Even though it's kind of black like this, but it's -1 right there. This is a very large range from -1 to 1. I want to map it back to 0 to 1, right? So that's a simple job. Just use a map range node, connect this in like so, from min to -1, from max 1, and this is 0, this is 1. Okay, so now we have a range from 0 to 1. Here we have 0, and here we have a nice transition to 1. Anyway, the wires are a little bit of a mess, so let me just go ahead and manage the wires a little cleaner. All right, it's a bit better. So let's test the result. We can now move the threads like that. So this is the displacement for the horizontal thread. And the next problem we need to tackle is the displacement for the vertical thread.